resistors and capacitors in series and parallel, and I'm Nathan Boggs. In this video, I will discuss some definitions and what to do with resistors in series and parallel and capacitors in series and parallel. So what are resistors and capacitors? A resistor is a passive electrical component with the primary function to limit the flow of electrical current. It is represented by this symbol. Capacitor, which has the ability or capacity to store energy in the form of an electrical charge, producing a potential difference across its plate, much like a rechargeable battery. A capacitor is represented by this symbol. So resistors in series. To find the equivalent resistance, all you will simply do is add up each resistor value. R1 plus R2 plus R3, so on and so forth, will give you R equivalent. Resistors in parallel are a little different. What you need to do is you need to add the inverse of each resistor. So 1 over R1 plus 1 over R2 plus 1 over R3, so on and so forth, will equal 1 over R equivalent. For capacitors in series, to find the equivalent capacitance, all you will do is add up the inverse of each capacitor. And if you notice, the equation for capacitors in series is much like resistors in parallel. So 1 over C1 plus 1 over C2 plus 1 over C3, so on and so forth, will equal 1 over C equivalent. Capacitors in parallel act much like resistors in series. So all you will do is add each capacitance. C1 plus C2 plus C3, so on and so forth, will give you C equivalent. So in conclusion, we discussed what a capacitor and a resistor are and how to deal with resistors in series and parallel and capacitors in series and parallel. Here are some sources in which I gathered some of my information, and this concludes my video project for Dr. Kono's class.